Hello, and welcome to another video. In this video, I want to go into detail about a couple of things involving proofs. Okay, so first of all, I want to talk about what is a proof. Like, why do we use it, and why does it have anything to do with math? So, a proof is just like the word explains it, you're trying to prove something. There are a few ways to set up a proof, but if you did the UNO assignment, you know that we are exploring T-charts. So a T-chart looks like this. We've written a T, and on the left side it's statements, and on the right hand side it is reasons. So it's like, why did you do the thing that's over here? Now the reasons that you use are also going to be called postulates. Oh, pen stopped working there for a second. Glitching. So postulates. Postulates are like facts that have already been proven. Okay? But you can also use theorems as reasons. And theorems are exactly as they sound. They are theories. Okay? But you can use those as backing to justify something. So that's why I like to use UNO as a starting point for proofs, because it's an introduction that shows you, each card that you lay down, why are you laying it down? So if you did that previous assignment, I explained in the first 10 slides how to do a proof for UNO. But I just want to do an example so that we're all on the same page in what a proof using UNO is. So it gives me this yellow 1. That's my starting point. And it asks me to prove red 2. So what I'm trying to figure out is how I'm going to get from point A to point B, right? And if you were playing the game with a friend, how could we use these two cards to get there, right? So we're going to set up a T-chart. I'm just going to do it on the same page here, so if I run out of room, just ignore that. So we have the statements on the left, and the statements in this case are our cards. So these are the cards that we're using. So on the right side is going to be our reasons. So why did we play that card? Okay, and I explained all of this in that video, but I'm just going to go into detail a little bit more. So we're starting off with the first card that we're always given, right? And so in this case, it's yellow 1. And what's our reason for using yellow 1? Well, we really don't have one. It was just given to us. Okay? So if it's given, then we're going to play our next card however we need to, whatever card we need to use in order to get to our red 2. So let's see, what card can we use next after the yellow 1? So I would say the yellow 0.
The interruption. Going to give you the standings of the...
Sorry, there was an announcement in the background. Didn't want you to hear all that. So we go from a yellow 1 to a yellow 0. Why? What is our reason for playing the yellow 0 on top of our yellow 1? So you might say because it's the same color. So that is our postulate for UNO. That's one of our postulates that we can use. It's our reasons. So we go from using our yellow 0 because it's the same color, and we're going to lay down our red 0. Why did we lay down our red 0 on top of the yellow 0? because it's the same number. I'm just going to put a hashtag here for same number. Okay? And then lastly, we get to our red 2. And why did we use red 2 after using red 0? Because it was the same color. And there you go. That is a proof for Uno. So we're going to do this in a couple different ways, and we're going to start off with algebra. So we started with a proof. That's a game that you know, a game that you play, you're comfortable with it, you're familiar with it. So we're going to take that, and we're going to go to proving some algebra steps. And then we'll start proving geometry things. So that's what you're going to do after this. So I'm going to look at this, and I have a problem here. It says that I'm given and I'm going to write this down because you can't see it as well. It says I'm given 8x minus 34 equals 6. And it wants me to prove that x equals 5. So when you have this algebra problem, I want you to think of what steps you use, and it's always good to write it down, like do a rough draft kind of thing when you're writing proofs. So first think about, like, how am I going to get x alone, get it by itself? So I would say the first step would be to get 8x by itself. In order to do that, you're going to have to add 34 to both sides. Okay? So when you add 34, so our first statement is 8x minus 34 equals 6, right? And what's our reason for that? Well, it was given to us. Okay? So when we add 34, we're using the inverse operation. Okay? And we add 34 to both sides. That cancels, ends up being 0. 6 plus 34, that's 40, equals 8x. Okay? So we end up here with a statement, 8x equals 40. Well, how did we get from this one to this one? What did we do? Well, we added. So your postulate for adding instead of subtracting is the addition postulate. And what postulate do you know that uses addition? And that would be sorry guys, I got a phone call. So that would be the addition property. And if you remember, it's the addition property of equality. So that's your reason, because that's the addition property you added, okay? So then let's see. Now we have 8x equals 40. Well, what are we going to do here to get x by itself? We're going to divide by 8. Okay, so now we have now we're left with, so now we're going to use the division property of equality. Okay, so now we have x equals 40 divided by 8. And what is that going to be? X equals 5. So now we have proven that. So that's it. That is all of that proof. Let's try another one just to see how we're doing. Okay, so you can pause this here and you can do it on your own and then come back to it. But we have given 4 times 2x plus 1 equals 76. And sometimes you may need to look up these properties to remember what they are. But it's algebraic properties. If you Google algebraic properties, you should be able to find them. But in most cases, I'm not going to ask you to come up with it yourself. I'm going to give you options to put in there, and you'll know. So that's just my opinion. I don't want you to have to remember properties from way back when. Okay, so the first thing we have here is this, and we want to get x by itself. So 4 times we're actually going to distribute here. Okay, so that we can keep solving the problem. So so we're going to start off with what we're given. 4 times 2x plus 1 equals 76. Let's think about what we do next. Okay, so next we're going to say 4 times 2x, that's 8x, plus 4 equals 76. So now we have 8x plus 4 equals 76. And why did we do that? Because we distributed. So that's just simply the distributive property. Okay? Alright. The next thing we're going to do is we're going to subtract 4 on both sides. Okay? So now we're left with 8x equals 73. 8x equals 73. So what did we do there? We subtracted. So subtraction property, I'm going to say of equality. I'm just going to put an equal sign. Okay? Then we're going to divide by 8. So now we're left with x equals whatever 73 divided by 8 is. And it is 9.125. Okay. So again, we divided. That was the division property of equality. And that right there is your proof. So these are just steps of developing a algebraic proof, and soon enough you're going to be doing some geometric proofs. So in the next assignment that you have, you're going to be going through some different things within, geometry, and you're going to be placing those tags where they belong in the proof. So I want you to think about, like, when we talked about complementary angles being 90, right? So if I gave you an angle and I said angle 1, let's see, A, B, C, D. And I told you that ABD was 30 degrees, right? So I said angle ABD is equal to 30 degrees. And then I told you that angle ABD and angle CBD are complementary. So both of those statements are given. So when you're writing out your proof, okay, so that first line is given, okay? And then that second line is also given. But you're trying to figure out what is, and your prove, so prove that angle CBD equals 60. So follow along those steps, and how would you do that? You would subtract. You'd use the subtraction property of equality, because and one of your reasons would end up being that it's the definition of complementary angles. Okay, and you would use subtraction property, so think of things like that as you're going through the next assignment. And I'll catch you guys later.